Okay, so welcome back. We are discussing this averting behavior method, right? And there we are saying that how our behavior, the way you are changing your behavior can be expressed in terms of some expenditure, like either in terms of time or in terms of the cost incurred, and that will be predicting the value of the let us say particular illness or any of the non-market environmental bads. So, in this extent, as you understand, we are discussing this topic. The very objectives of the topic is to develop or to estimate the economic benefits of many policies, let us say health policies that target to reduce the a kind of mortality, let us say premature mortality, or the number of times we are falling sick. So, that is morbidity. So, here in this context we are actually developing a model, that is the Averting expenditure model, based on the theoretical underpinnings of utility maximizations, and again the predicting variables that express this utility maximization is based on the observable behavior. So, that is why it is a part of your rebel preference method. So, that is what we are continuing from. And in this context, what we have already done. So, we have expressed the utility functions, and we have also expressed the total income constraints, that is in terms of income from non-labor source and income from the labor source, that we have discussed. So, from that once these functions, utility functions and your total income constraint functions are framed, now it is our task to estimate the willingness to pay, or which is also known as the consumer surplus. And this consumer surplus is actually has the theoretical understanding or theoretical synonymous to the compensating variation for change in the particular environment, that is let us say change in pollution. So, if you have to find this or estimate this willingness to pay from these two functions, that is utility functions and your income constant, what you need to do? We need to solve this utility maximization problem that we have discussed in the last class. And then what we have to do? We have to substitute the equation 4 in this utility functions. And do not forget that this your equation 4 is your health production functions. So, what we have to understand? We know what is the utility function of a particular individual. So, I am just repeating that here utility function of a particular individual depends on the consumptions he is making in XYZ, whatever the goods and service he is doing, and also the leisure time, that how many times or how many hours the individual is taking rest or a kind of doing a kind of recreation. And the third one that is essential here is the number of hours or number of days he is falling sick. So, accordingly the utility function of a particular individual can be finalized, and this is what we have already discussed, right. So, based on these utility functions, we have also added the health production functions, right. So, in health production functions, we are saying that when you are falling sick, it is not just like you are falling sick without any cause. It has some cause and it is attributed to your behavioral causes, right. So, that means if you are taking enough number of strategies or enough number of precautions, then obviously the probability of falling sick is less. So, based on this understanding, the health production function is made. So, here the health production function is represented as is. Again, these are the variables which are expressing or which are explaining this S. So, here G is the mitigating behavior or mitigating activity the person is taking in order to avoid the sickness. And again E is the exposure from the pollutions, and here we are assuming that if the pollution degree of pollution or extent of pollution is high, then it is very high that the person will be falling sick. And to express this exposure, again we have taken into account two other variables, one is A and second one is alpha. So, what is this A? So, this is the averting expenditures, right, and this is mitigating activity. We have done drawn a difference between what is mitigating or mitigation activity, and this is the averting behavior or averting expenditure that the person is making. And the second one, this alpha is the ambient level of pollutions. That means, beyond a particular level of pollutions, then if the further pollutions are added, then obviously the person is going to fall sick. So, that is what is explained as the ambient level of pollutions. And Z is the other variables take into account. You can take some demographic variables or socio-economic variables, sometimes we can take, but more generally it is the demographic variables. So, that are the age of a person. So, if you are young, then obviously the likeliness of falling sick is less, and it depends upon your age only. So, that we have discussed. So, now based on this understanding, what we have to do? We have to actually maximize this utility functions, right, if you have to find out what is the willingness to pay in this context. So, in order to maximize this utility functions, so what you can do, you can actually say you are just replacing or substituting this S, the value of S here. So, it is done x L, and for this one is substituted. So, your utility function is done. And if you have to maximize, then we need to see what are the constraints. So, these are the constant, this is the constant in terms of the total income constraints. So, as you understand, we already have explained it that this total constraint is the total income constraint is the income from non-labor source. So, that is in terms of I, and WT is the income from the labor, right. So, that means a person is doing some kind of labor and he is getting the returns or wages, and that is the portion of his income, and this portion of income is not actually from the labor. So, it is from a fixed kind of income he is getting, maybe he is getting some interest on his fixed deposits. So, again this we have already explained, right. So, this is the income constraint, and taking into account both these, what you can now do. So, the task is now yours. I am not going to detail that how it is solved. So, what you can do, you can actually take these optimization functions, or by taking this optimization strategies, you can solve these functions, right, and you can use this Lagrangian multiplier in order to find these functions. So, let us say suppose Z is this utility functions plus lambda plus this income functions constant minus this one. So, again the rest of the things you can solve by this optimization method. So, here what you want to say, that we can actually find the willingness to pay, or what is known as the compensating surplus or consumer surplus here. So, apart from this arithmetic exercise of doing this defensive expenditure, and what is the impact of defensive expenditure on the well-being of the person, if he or she takes some kind of some changes in the behavior, then in this context we can actually take some other exercises, that how the defensive function would be looking like if the level of pollution itself increases. So, let us say the initial we can graphically represent it. So, let us say in the horizontal axis we are measuring quietness, that means no pollution. So, it may be a case of your sound pollution or noise pollutions, and in the vertical axis we are measuring in terms of the monetary units. So, that means how the person or a household is measuring quietness, and that is why what is the amount he is willing to pay in order to have quietness or in order to decrease the level of pollutions. So, that is what the basic objective is. So, here what you can do, we can actually draw the defensive expenditure function initially. Let us say this is the defensive expenditure functions when the pollution in the initial case of pollution. So, this can be represented by defensive expenditure of Q and P1 is the level of pollutions. So, now what you are saying that our understanding is that when pollution changes, right, then what is happening to your defensive expenditure, and from that how you are going to find the willingness to pay or compensating surplus, right. So, here what we are saying that pollution changes. So, when pollution changes, then definitely this defensive expenditure will be moving upward, right. So, here let us say the defensive expenditure now would be explained in terms of D of Q P2, right, and the individual would be interested in a particular quietness, right. So, let us say it is represented in terms of Q star. Okay. So, earlier given this defensive expenditure functions or given this given his demand for this quietness Q and P1 level of this pollution, the individual is interested to consume at least this level of quietness inside the house, right. And now you are saying this the noise the pollution has increased, and that is why, and obviously the individual would be interested to maintain the same level of quietness, he is not going to compromise the level of quietness, right. So, for that reason what would be his defensive expenditure in order to maintain the same level of quietness, that we are discussing. So, here we are saying that when we are interested to consume the same level of Q, that is in terms of Q1 sorry Q star, then the defensive expenditure would obviously change, right. And when you are saying this pollutions or P is changing very slightly, very minimal change is occurred in the pollutions, then we can actually say that the marginal willingness to pay to compensate for the change in P. What would be the marginal willingness to pay to compensate for the very slight change in P, that we can find out, right. So, in this figure we just want to maintain this Q1 itself, and when you are saying that this this pollution is increasing, then the marginal willingness to pay would be equivalent to your compensating surplus for not to increase the level of pollution itself. So, that means now the households would be actually be compensated, or they would be actually trying to make some extra expenditure, right, so that the pollution itself would not be increasing. So, for that case, if we have already drawn these two defensive expenditure, take into account the initial level of pollutions and the increased level of pollutions, from the very defensive expenditure functions itself we can find out what is the willingness to pay, or which is also known as the compensating surplus. So, that means this area, the difference between these two area would be the compensating surplus or willingness to pay that the household is now willing to pay in order to decrease the pollution level, or in order to have the constant environmental quality, that is quietness inside the house. So, although the individual cannot actually influence this P or pollution outside, but what he can do is to control the quietness inside the house. So, that is why he needs to do this exercise, that what is the amount of willingness to pay he is prepared in order to maintain the same environmental quality, that is this much of Q star of environmental quality, right. Although he cannot actually control this P1. P1 will be changing or increasing P1 from P1 to P2 level, right. So, this is how we can say that when the pollution or any kind of environmental quantity or quality whatever we are focusing, they are changing, then accordingly the defensive expenditure function will be changing, and from this defensive change in defensive expenditure function we can find out what is the marginal willingness to pay, or which is known as the compensating surplus for the change in the environmental quality. So, now we will be trying to link that how this defensive expenditure and marginal willingness to pay, or what we are saying willingness to pay is related, or how it can be actually correlated. So, when you are saying that because of these pollutions, let us say we are in this context we are discussing this noise pollutions, then the pollution level is increased from P1 to P2 level. Then the question is, how does the observed change in this defensive expenditure, because defensive expenditure function shifts upward, how this change in this defensive expenditure is compared to the willingness to pay in order to avoid this pollution increase. So, that means here we are saying we are drawing these two things, defensive change in defensive expenditure and the willingness to pay. So, suppose say this defensive expenditure is just equivalent to your willingness to pay, right. Then obviously when you are saying defensive expenditure is willingness to pay, then this equivalence is expressing the demand for the noise pollution of that particular household. What is the demand? Obviously the amount he is doing or spending in terms of defensive expenditure, and that is what is equivalent to willingness to pay, if it is so. But it is not necessarily that this defensive expenditure would be equivalent to willingness to pay. Sometimes what happens, willingness to pay may be greater than this defensive expenditure amount, because as you understand from the very beginning we said that when you are going to do some mechanisms or install some mechanisms in order to avoid this noise pollution outside, and we need to maintain the quietness inside. So, maybe this equipment is not 100% successful in combating the noise pollution from outside, right. So, in that case, although the noise pollution or the quietness can be controlled, but it cannot be controlled as per our expectations. So, in that case this defensive expenditure may be less than the willingness to pay, or willingness to pay may be greater than the defensive expenditure, right. So, in these conditions, if it is so, like let us say this defensive expenditure, the amount of defensive expenditure is greater than willingness to pay. So, that means you are actually making more expenditure on this defensive mechanisms than what you are willing to pay. So, in this case it will be providing an upper limit of this willingness to pay itself, right, because we are not saying that willingness to pay is this amount, this number. We are actually talking about, given the change in the environmental qualities, this willingness to pay will be ranged from this to this, because the scenario would be different, right. So, here we just want to make this theoretical thing that this defensive expenditure, if it is greater than willingness to pay, then obviously this defensive expenditure will be providing an upper limit or upper bound for the willingness to pay. And if this defensive expenditure is less than the willingness to pay, then it will be providing the lower bound on the willingness to pay. So, that means here in this case you will be finding the limits of willingness to pay itself. However, this defensive expenditure method is not free from limitations. So, there are some limitations that have been identified this research by OECD in 2018. So, firstly you can say that this method actually presents a partial or lower bound estimate of the value of the impact of non-market bad on the very individual's well-being. So, why we are saying? Because when we are saying this defensive expenditure can be greater than or less than the willingness to pay, right. And generally we are saying this defensive expenditure from the because again this is a reveal preference method, and from our own observations from the literature that we are finding that although theoretical this is possible, but whatever our literature states that this or observation states that this defensive expenditure is generally less than the willingness to pay, right. So, that means these mechanisms of valuing the impact of non-market bad on the individual's well-being, it is actually representing some partial phenomenon, partial thing. It is not completely giving the picture or completely estimating the this is the value that the individual is actually putting for the non-market bad. And secondly, when we are actually discussing many examples, real life examples of averting behavior or defensive expenditure method. So, this averting behavior itself create joint products. So, what is joint products? So, let us talk about from our own common observation that when you are saying that meat production, right. So, meat production and leather productions are having a correlation. That means, when meat production would be increasing, particularly that you are butchering the cows, right, then this meat production would be increased, and also the leather production would be increased. So, the second phenomenon can be understood from the first phenomenon, or first phenomenon can be understood from the second phenomenon. So, this is what we are saying the joint productions. But in case of this averting behavior case, can you give some examples that actually will be best fit for this joint products? So, you can just think about, but we can discuss that when the averting behavior, just like you are saying you are using sunscreen lotion. Why you are using this sunscreen lotion? Because you want to avoid the sunburnt, you do not want it, right. And its the other impact would be what? You can reduce the skin cancer. Don't you think that applying or using this averting behavior, expressing this averting behavior, and then doing this averting expenditure, it is producing two products. One is you can save your skin from sunburn in the short run, and in the long run you can reduce the skin cancer. And most of these averting behaviors, they are creating this kind of joint products. But the issue is that if you are interested only in your policy analysis is only concerned about the sunburnt, right, then you cannot actually explain this one, the how the same application or same expenditure can reduce the skin cancer, right. So, we need to actually take into account how it can be apportioned. So, this is again a task or limitations in this method, that how it will be proved, how we can say that this is expenditure is this expenditure you are doing only for the sunburnt in order to avoid the sunburnt, and this expenditure, this portion of the expenditure is only done in order to reduce the skin cancers, right. So, this is what this is a challenge. And thirdly, you can say that it is not easy to assign the monetary value to our behavioral changes, and that is associated with your defensive actions. So, it is very difficult to actually assign the monetary value always. Let us say you are saying the case of time. when you are saying this averting expenditure or defensive behavior, so it can be in terms of either time or in terms of actually doing purchasing some goods or techniques or some technology to avoid the particular environmental bad, right. And when basically it is this averting behavior is expressed in terms of time, right, then you are saying that this time can be actually monetized, expressed in terms of monetary valuations by taking into account the value of time for those individuals. So, that is in terms of wage. So, how many of wage hours are lost because of taking this averting behavior, and that is why what is the amount of wage lost because you have practiced this behavior or change your behavior. But in case of in the last class we discussed about this thing, that when we are saying that the children are generally kept indoor in order to avoid the air pollution, right. And let us say the we know that from very different sources we got to know that this is the peak hour for the pollution, and that is why the children should not be exposed to the outdoor. So, we are trying to keep them inside the house, right. And when they are not going to the outdoor cases, or they can actually at that time they could have their own recreational activities outdoor, but they are bound to be inside the house, right. Then how this time would be measured? Can you measure, can you express this, explain this in terms of these monetary units? Because children do not earn anything. You cannot say that the wage for them is this much, no, there is nothing. So, this is the same logic applicable for the old age or retired persons, right. So, that is why you can say that it is not actually easy to assign this monetary value for any kind of behavioral changes that is associated with the defensive actions, right. So, the last but not least, you can find so many other limitations that we are not actually discussing here. So, here we just want to say that in case of the presence of some of the unobserved factors, right, that actually related to the behavior, the very averting behavior that we are changing, or and it is also related to the outcome of this averting behavior, that is in terms of health outcome, right. And here we have taken some variables that are explaining these variables, and some of the variables that we are not taken into account, that means they are unobserved, right. So, in this case, if some of the variables are unobserved, they are not taken in your model, or they are not taken into account while predicting what will be the how the individual will be valuing because of this bad. So, in that case it will be difficult in causally identifying the effects of the pollution and on the health outcome. So, for example, you can say that it is a case, so we can actually extend the same example of children's, they are actually kept inside, right. And we know that some children, they do have good immune system, natural, they do have this natural capacity to bear these pollutions, and some of the children, they are actually weak, they cannot actually tolerate if they are exposed to the pollutions, right. But these natural systems, right, that is inbuilt in the children itself, they vary from children to children. But how this unobserved value or unobserved variable, that is the natural immunity systems, which is impacting the behavior itself, the behavior that suppose a X child, he is strong, that means his natural immunity system is strong. So, he can be exposed to pollutions, he can tolerate, and there will be no effect, he will not be falling sick. But still and there is another kid X2. So, he is actually having this poor immunity system. So, as a result, when you are actually forbidding doing the same behavior for both the children, and you are not actually taking into account these natural systems into account, and it is actually related to the behavior as well as the health outcome. So, in that case, that is a causality. We cannot actually, there is a difficulty in causally identifying the effects of the pollutions and the averting expenditure, averting behavior, that is in terms of the health outcome. Okay. And in this method also we can identify some recent developments, right. So, first of all, that recently just now we have discussed about the causal identification is a problem, and recently we actually developed some strategies so that we can identify, we can address this causal identification problem. And moreover, some of the econometric approaches now we have already developed in order to tackle these identification challenges. And moreover, in the recent literature we are finding this there is a combination of averting expenditure with the stated preference, either the contingent valuation survey or choice modeling, in order to evaluate this non-market bad. And these are the suggested reading that you can follow, but you must follow this primer on non-market valuations, and for the limitations and recent development you can follow this book, 2008 book. So, that is all about the averting behavior method. Thank you.